In the AWS Developers Podcast, today we're talking about document processing pipeline. I know it's vague, it's abstract, but stay tuned. We're going to explain all the details. Good morning, good afternoon. Welcome to the AWS Developers Podcast. I'm with Brooke Jamieson, your developer advocate, senior developer advocate at AWS. Thank you for co-hosting this AWS Developers Podcast with me and with Dave before. The long-time listener know your voice already because you're a long-time contributor to this podcast. And we have the pleasure to welcome Halim as well. Halim Qarroum, your head of application prototyping based at AWS in Luxembourg, and you develop with your team an open source framework to process and to create pipelines to process documents. And that's what we are going to talk about today. Halim, thank you for being there. Maybe we can start with a very basic high-level question. What is a document processing pipeline?
Hi, Sebastian. Hi, Brooke. So essentially, in a nutshell, a document processing pipeline it's an automated system that takes in various types of documents, typically involves some pre-processing where it cleans those documents and formats them, and then analyzes their content to extract useful information from them.
As part of your prototyping job, you have to develop this type of pipeline for customers. So what is the typical use case that customers are asking you to implement to process documents?
First, I'm probably going to talk a bit about if that's okay, the reasons that led to the creation of Lakechain, why we created it initially. And that's for different reasons, but first and foremost, it originated from a time to market problem. So we have a lot of customers, looking to build machine learning or generative AI application pipelines, but we realized that the effort at the time, so we're talking between end of 2022 up until today, between creating a successful proof of concept and putting it in production was just too high, right? So whether this was integrating private data with LLMs, with, techniques like retrieval augmented generation or content generation, whatever it is, all boiled down at the time to a lot of experimentation, manual work, and there simply was no shortcut to putting such a solution in production with the scale, the observability, and the security that's required by our customers. And the second reason was more targeted at our team. So we work with a lot of customers each year, and we build with them what we call rapid prototypes of use cases, primarily involving machine learning and generative AI. And we required a way to have the modularity to build pipelines in a very quick and efficient manner.
Yeah. And this sort of like modular prototyping piece is something that especially AWS customers are used to, because that's what AWS makes easy for so many other different types of development. I think it's always confusing for people when they come in and they're like, what do you mean we don't just have the building blocks to build something new together? Because they're so used to having all of these building blocks ready. So projects like this one are a really good example of doing what AWS customers have expected the whole time.
Yeah, no, exactly. And we have, I don't even counted something like 270 or 80 services. And what we're doing here is that we're putting them together into a coherent framework where people can just, declaratively describe what it is that they want to do.
So what's the typical flow that a customer can build with Lakechain?
Yeah, so essentially, and we call this the hello world of Lakechain in a way, which is available on our quick start guide on our documentation on GitHub. So typically, a very simple example that we give to newcomers is I think it's an 80 lines of code example, something like that, where we show you, okay, so there is this data source, let's say S3 bucket that can, where you can upload documents like images, pictures, for example, and you simply want to blur the faces of all the people on those images, right? Mm-hmm. Pretty common use case overall that you can achieve in about 80 lines of code. And the way it works is that Lakechain introduces this concept of, processing blocks. We call them middlewares that developers can chain together. So in the example I just gave, that would be, okay, here's an S3 bucket that is owned by a customer where they can upload new pictures. And we want to trigger a pipeline every time a new document is uploaded there. So you would have typically what we call a trigger middleware. We have one that's called S3 Event Trigger that you can instantiate inside of your code that will listen in for those documents that you can then pass over to another middleware, for example, the recognition middleware that integrates seamlessly with Amazon Recognition to detect the faces and the bounding box around the faces within these pictures. And then you pass that to another middleware that will take those bounding boxes and simply blur out the faces of the people. And then you have a last middleware that will store, the transformed pictures somewhere else, for example, into another S3 bucket.
Yeah. And when you're talking about recognition in this case, so this is already an AWS service. So it's for image recognition and video analysis with machine learning. So it's not that you're taking over that recognition piece of it. You're just chaining it together in a way that's useful for prototyping, just to drive home that point for people. What do people use other than recognition in some of these simple examples? Do they use other machine learning services from AWS or different things?
Yeah, absolutely. We currently have about 16 line integrations in Lakechain. So in terms of AWS services or AWS AI services, we have recognition for images, recognition for videos. We have an integration with Amazon Bedrock, where customers can leverage the many generative AI models that are there. We have integration also with Amazon TextRect, where we're currently building an integration with it. Amazon Poly to synthesize the voice. Imagine you're creating an article and you automatically want to create, synthesized speech for that article to publish it on your blog or on your advertisement website. Online, we have integration with Amazon Transcribe, Amazon Translate, many integration, basically that we're making super easy to chain together.
You convince me. One of the challenges I have with this podcast is every week I need to re-listen to what we registered, what we recorded, have a short transcript to add to the podcast application, and then make an even more condensed summary to post on social networks. So that would be a workflow. I start with my MP3 file on S3, I summarize it, I transcribe it with Amazon Transcribe, I summarize it with Bedrock and a large language model, and then I post the output. I send it by email to me, so I receive the text ready to copy paste on social networks. If I want to get started with a use case like that, where do I start? What are the prerequisites, and what are the different steps to build such a pipeline?
Sure. So to get started, the two things you'd need is one, an AWS account. So you need access.
Makes sense.
Yeah. And two, we require new joiners to have some familiarity with some AWS concepts, at least on the high level, and also with the AWS CDK, which is the AWS Cloud Development Kit, which is AWS's solution to write infrastructure as code. So this is a product, it's open source, that we provided many customers use to deploy solutions and their architectures on AWS, right?
Okay.
So those are the two prerequisites. And coming back to your example, which is, a very, very frequent example we're getting, where, you, in a similar way, you want to listen in for like audio recordings from an S3 bucket. So you would use, for example, our S3 event trigger component middleware to listen in for any events associated with that bucket. What the trigger does is that it compiles, a description of the document that can be interpreted by any middleware within a pipeline. Then the other thing you do in your code, and we're talking about CDK code here, you can literally instantiate the transcribe, we call it the transcribe processor, which can take in audio files and produce text transcripts, and then pass that to the Bedrock processor. You give it a prompt like summarize, the text associated with this meeting audio recording, extract the main key points or the main call to actions associated with that meeting, and store all of that on S3, or send me an email while that's done.
So it would be like 50, 60 lines of code, and then I just type CDK deploy, and that's pretty much it. I have the pipeline ready to use and to test.
Yeah, exactly. The CDK deploy will take the CDK code that you have written and essentially compile it and deploy it on your AWS account. So the whole setup is extremely repeatable. It is auditable. So you can deploy it on a personal development account. And once you're ready to go with it, you can deploy it on a staging account or a production account later on.
That's the beauty of the CDK, the repeatability. I can deploy the exact same infrastructure across multiple regions or accounts.
Yeah, for sure. Especially getting data into Bedrock, like you were talking about, this seems super useful for that. Lots of the times people want to use, all the exciting data is unstructured normally. So it's a nice way of being able to get some structure out of that so you can do cool things with other prompting in Bedrock.
Exactly. So the really cool thing about Project Lakechain is, as we said, you literally define your pipelines as code. And that code is very compact, easy to read, easy to write, and automatically translate into a complex infrastructure behind the scenes once you deploy it. And we do abstract all of that complexity from developers. So imagine things like security group configuration, things like IAM roles, which can be sometimes tricky to write well with optimum security, things like auto-scaling, logging, monitoring. All of that is abstracted away and makes it possible for customers to focus on the logic of their pipelines instead of having to worry about the underlying infrastructure. So as you said, Brooke, things like, prompting, giving the right prompts to a GenAI model, those kind of things where you describe what your pipeline should do without having to worry about the rest.
Yeah, for sure. And how does that abstraction help you to handle the different document formats so you can really ensure that interoperability between the different middleware you're working with?
So we have developed something we call an ubiquitous language, basically. That is, so it's a standard specification within the project itself, within the framework itself, that is based on a high level on the cloud event specification, which is a specification to which AWS has contributed to in the past. It's primarily a specification to allow microservices to talk in a normalized way to each other. But on top of that, we're adding a semantic layer to describe any types of documents, whether that's a video, whether that's an audio file, whether that's text, whether it's PDF, whatever it is, we can describe this using this ubiquitous language that constitutes the glue between all middlewares. And another thing we do is that we have a type system within the framework. So essentially, when you describe your pipelines, when you instantiate all of those processing blocks or middlewares, as we call them, they are types. So, for example, a transcription middleware essentially takes in a bunch of audio files as an input, right? And outputs a textual representation of that transcript, right? So a plain text document. So every middleware is self-describing in that sense, in the sense where they describe what they support, what they don't support. And the nice thing about it is that you're getting type inference at compilation time. So when you have described your pipeline and you want to deploy it on your account, you get compile time exceptions when something is not right. So for example, you're trying to pass in, an image to a transcription middleware, which doesn't really make sense.
Let me rephrase that to be sure I understood correctly. It means that the Lakechain project defined a libraries of types for document, like a PDF, an image, a sound, different types of sound, different types of image or video. And the middleware, so the different bricks that I can chain together in a pipeline, express the types they can accept as an input and the type they can accept or they produce as an output. And often it's guided by the semantic of what we want to do. If we want to transcribe an audio file, obviously it takes an audio file as input and it generates text as output. And these types are modeled as code using Java or TypeScript or something like that, so that the compiler will enforce that two middleware will work together by consuming the content that has been produced by another middleware only if the type is correct for the compiler, just like an int and an int or string and a string. Yeah. So it means that I can't even deploy an infrastructure which is incorrect. My errors will be catched by the compiler even before I deploy.
Yeah, that's absolutely right. And this removes the frustration experienced by many customers entirely that have to deploy on the cloud to find out those errors within their code. Here you get most of the stuff, are raised at compile time.
That's a subject we addressed already a few weeks ago in the podcast. Go back to episode 126 from mid-August. We discussed with Gregor Hope, an enterprise architect, that define exactly that. He called that domain-driven design applied to the cloud, where we can add semantic to the cloud. Yep. We started from we started from the fact that a YAML file or a JSON file that describe infrastructure, it's just strings everywhere. There is no type on that. There is no semantic in there, or the semantic is implied. So what if we can use a higher level programming language to actually express semantic in such a way that the language itself or the compiler will prevent us making mistakes and catching these mistakes much earlier in the development cycle? And that's a fascinating aspect. There are new programming language like WingLang, for example, that address this type of problem as well. How is it working behind the scene? Because, okay, I said I type CDK deploy and magically the pipeline is deployed, and I get that the main components are actually AWS services. We talk about Transcribe, Bedrock, S3. But how do you bridge them together? What is the glue? Are you deploying a Lambda function and step function to synchronize, manage the retries? How does that work?
Yeah, so the heart of the project lies in its messaging system, which is the core element that allows middlewares to process documents and communicate with each other. And to model pipelines, which we call DAGs, or directed acyclic graphs, which is a barbarian term to essentially express a graph that it doesn't have any cycle and that has a direction. It only flows into one given direction. And to express those, we use at the heart of this messaging system, we use SQS and SNS as the building blocks for the messaging system itself.
Only SNS and SQS? There is no Lambda function, there is no step function to orchestrate all these? You're building a network of pipes, literally pipes, because SQS, it's a queue, so I like the idea of a network of pipe. As a workflow orchestrator, there is no code?
There is no runtime code involved in the orchestration of the pipelines. And the reason for that is, well, one, for starters, simplicity, but also cost. And I'm going to talk about cost entirely. This was a big subject in the design of the system. Cost, high throughput computing, because Lakechain is a high throughput computing framework. We wanted to use the least amount of services. At the core, you can, of course, in your middlewares, that invokes Amazon recognition or does transcriptions, there are Lambda functions running in those middlewares to do those things. But the orchestration of the middleware itself, it is only based on SQS and SNS, and we can do everything with only those two services.
Wow. Naively, I would have implemented with step function and maybe a couple of Lambda function when I cannot have step function do what I want. Why not? I mean, what was your main driver for that type of implementation with SQS SNS?
No, that's a very good and legitimate question, I would say, because that would be our first choice as well. And step function is a really great service. The reason we started with SQS and SNS is that essentially those two services allow us to provide unprecedented scale to our customers. And we have a lot of customers, big customers, big enterprise that have millions or dozens of millions of documents to process. So they need huge throughput, huge scale. To provide a perspective on the scale of SQS, in 2023, during Prime Day, Amazon.com, our e-commerce website, set a new traffic record for processing 86 million messages per second at peak using SQS.
Per second.
Yeah. Per second, yeah. And the second reason is cost, right? So we want to do, high volumes, low margins, right? So that's our model. It's also the model of Amazon in general. So we want to provide the most optimized solution at a very low cost. And to do that, we have to remove any middleman possible in the system. And to give you an order of perspective on step function, that we work with a lot, actually. There are some middlewares implemented with step function, but the core messaging is only SQS and SNS. We're 25 times cheaper than step function standard. So when you're handling millions of documents, that's a pretty good reason. And regarding step function express, which is a bit lighter weight version of step function standard, we're 20% cheaper than step function express for orchestration.
For sure. So obviously it's really difficult to predict even what will happen in AI and machine learning next week. But have there been design decisions you've made during this project to make sure you're ready for whatever the future holds? Or have there been things you've thought about in terms of future-proofing as best you can for developers working with this?
Yeah, so that's a very good question. It relates to the biggest challenges we've faced when building this project. I started building it something like roughly a year ago mostly as a side project, a real job. But essentially, one of the most difficult problem we had to solve is abstraction. So how do you think about abstraction when, and you're rightfully saying that you cannot predict what, or we don't know what's going to happen next week. Maybe you have developed a middleware that can only handle text as an input, but then we had multimodal models that came in and that supports images in addition, and a collection of images in addition to text. Tomorrow we'll probably get audio and video also as an input. The outputs will change. It will not only be text, will probably be video in a few months. So thinking about what's the level of abstraction we want to implement, not to forbid any use case that technology would make possible tomorrow by using the framework, right? And I'm going to give you a very simple example that doesn't even relate to AI, something really simple that a lot of developers can relate to, which is FFmpeg, which is, Sebastien used to say is the Swiss Army knife tool of video and audio processing, right? And we do have an FFmpeg middleware, but FFmpeg is so powerful, is so complex. How do you even abstract in terms of an API everything it can do? And the answer is you don't. You don't, because this is impossible. And you need a Turing complete language to describe what you do with it. So we had to think about all of this stuff. What is, simple use cases that we want to make super simple, and what are the more powerful interfaces that we make available to developers to take advantage fully of the underlying system that they're using.
Yeah, definitely. If developers are new and they haven't heard about abstractions or sort of thinking in this way about computer science, there's a video on the AWS CDK product page website from Werner that's really good. And he talks about like everything, why Cloud Development Kit is the way it is and how this helps you to build. So I really recommend we'll add it to the show notes, I'm sure.
And you don't have to search for it. It's in your podcast application. In this episode note, you have the link to that video. So
yes,
scroll down a bit and go watch this video after this episode.
Yes.
What did you learn while you were building such a large framework? What are the challenges that you had? It's a question I like to ask to my guests so that other builders, other developers that are listening to us can know the part to pay attention to.
So, it was the amount of knowledge we accumulated was immense, mostly over two fronts. Well, first of all, we don't only integrate AWS services in as middleware. We also integrate, open source, some of the most used open source machine learning model that customers use, and we integrate them into the framework such that customer don't have to deploy them themselves, figure out how to scale them, and so on. So the first thing you need to learn is how do systems work. You need to become almost an expert in them, in how those models work, what services they provide, to be able to define the right API or abstraction in your system for people to be able to consume them, in the best way possible, and use cases that actually make sense, right? So we had to learn how those external systems or platforms also work. The second thing, of course, is around generative AI, understanding what use cases we can achieve with generative AI. Actually, one of the most prominent example we have, and we have about more than 50 examples on the repo. One of the example is simply how do you generate a podcast from arbitrary data? Like the example is literally, let's go fetch the AWS News RSS feed, figure out what were the news of the day, right? If there are no news, there's no podcast. if they're in use, they're compiled together. The RSS feed is automatically parsed out. It's converted into text. We have a middleware that can go on a web page. It removes the entire HTML out of it. It only extracts the textual substance from that article. And then we group all of those documents together in a MapReduce fashion. And we pass that into an LLM. And we say, look, we have, 12 new articles on AWS today. Write a podcast with, 2 or 3 people talking together. And then we isolate those voices. And we synthesize them in parallel using different voices, male and female, to make it, entertaining and realistic enough. So, and at the end, we compile all of those audio files together again and produce a single MP3. And there you go. You have, an almost real life podcast.
Okay, maybe I should search for a new job then as a podcast host. That's not a good place to be. It's funny that you mentioned that example because a couple of solution architects recently in an internal hackathon developed a similar solution. It was they were not using Lakechain, but they had the same idea of federating the RSS feed, generating a text, synthesizing, it's difficult for me to pronounce that word, a voice based on that, and have an audio podcast based on that. And they did that with my voice. They trained system to talk like me based on previous podcast episode, and the result was really, really, really surprising.
Yeah, then you really need to worry then.
Oh, by the way, if we want to do that with Lakechain, like call a third-party API for which there is no middleware today, what's the recommended approach? Should I write a Lambda function and call it from Lakechain? Should I write a new middleware in Lakechain to wrap that external API, external system? What would you recommend?
So that's a very good question. So we have a transform middleware that's generic, where you can call a Lambda function to do arbitrary actions and then transform those actions into a document that the rest of the pipeline could process, right? So it's kind of an adapter for an arbitrary Lambda function that could call one API or do whatever it needs to do, right? And your question raises also an interesting part about Lakechain, is that it's not a full stack framework, meaning it's not some crazy, super opinionated thing that, you have to rewrite your entire thing in Lakechain to begin with. You can integrate it into your existing stack. And if you have a Lambda function that makes a call to a third party, for example, synthesizing API, for example, then you can integrate that within an existing pipeline, within an existing project, right? So as long as it's CDK, it will work.
Okay, so for developers interested in contributing or building on top of Project Lakechain, what resources or tips can you give them to get started?
Currently, don't accept new contributions regarding middlewares. We are going to start accepting contributions for middlewares normally in September 2024. And so by the time this podcast comes out, basically, the reason is that we're going to transition the project from an alpha version to a beta version, where all the features are available, and we're looking for feedback and new contributions from people. So we are currently writing a guide that will sit inside of the official documentation. How, as a developer, how do I write my own middleware? How do I contribute to the project? How do I enrich it? Because that's the number one question I've gotten so far. So we're working on it, but at the same time, we have waited for quite some time to stabilize an API that we're happy with, to avoid any frustrations, down the line of having people having to rework their middlewares just because the API has changed. But other kind of contributions we do take today already. Actually, we have already internal and external customers that have contributed heavily in the past few months, which is around feature requests, bug reports, and requests for comments, where customers have an idea, they just want to understand how Lakechain can help them, and they write to us, they open an issue on GitHub, and we have predefined templates there that are quite clear, where developers are very welcome to ask us questions.
And we like to finish these episodes with a note of perspective. Where are you going? So you already mentioned that the project will move from alpha to beta and stabilize the API. That's the next step around the publication of this episode. So if you're listening to this episode, that phase is done, probably mid of September 2024. What's next? What are the things you're looking forward to improve this project?
So we have the public roadmap on the GitHub repo. We aim to build in public for this project. So we have divided the roadmap into 3 main categories. So the first one is keeping the project secure. So everything that relates to keeping third-party models, third-party libraries up to date at any time is something that we spend a fair amount of time doing. The second element is keeping up with our own services. And we're discussing about that previously, Sebastien, that, especially in generative AI, Bedrock is evolving almost every week, right? With new models, with new capabilities for customers. And we spend a fair share of our time keeping up with those updates and making sure that Lakechain exposes all of the functionality that the native services have. And the third element is new middlewares, new features, new capabilities, new examples. Also, the end-to-end examples we have on the repo have been deployed on AWS accounts a fair amount of times, so they're pretty popular, especially the podcast one. And identifying, generative AI the landscape is evolving every day, but what does it really make sense for customers, right? So we spend a lot of time speaking with them, working with them, defining what models we should integrate, what new libraries or functionality they would like to see in a document processing system as a whole, I would say. And then it's all about, bug fixes. We had a lot of conversation with the customer that also wanted us to implement some, advanced security features within the project. So for example, how do I ensure that I can define an entire processing pipeline and everything runs within the boundaries of a VPC that doesn't have any internet access? How do I even do that? So those kind of requests that we get from customers is, at the center of the features we're gonna develop in the next months.
Halim Qarroum, your head of prototyping at AWS and main developer for the Lakechain project. So go ahead and try. If you have document processing pipelines, I think the easiest way to learn what we talk about today is to install the package and write your first pipeline, and then CDK deploy and see the magic operate with Lakechain. Brooke, thank you for co-hosting this podcast episode with me. Halim, thank you for your very clear and complete explanation. Thank you, listeners, having listened to this episode until the end. Next week, we are going to talk about how to get ready and how to get prepared for the Architect Pro certification. And we will host Patrick. Patrick Sarr is the co-author of a book explaining you how to get ready, how to get prepared for that Architect Pro certification. If you're planning to get certified in the coming months, be sure to subscribe and download and listen to the episode from next week. But now, go build.